Okay, we have our login to cloud.gov. Next step in order to get working is to make sure we have the Cloud Foundry command line utility installed so you can actually start deploying apps. Why? Well, the Cloud Foundry command line interface is the main way of interacting within cloud.gov on a hour-to-hour basis. It's a multi-platform binary written in Go that lets you interact with the API that drives everything. Some of our services are available through our dashboard, primarily ones that may be used by program managers who have less reason to use the command line interface day by day and just need to come in and check on the status of things and make sure that roles and permissions are correct or to remove someone from a project. Pretty much everything else is going to be available through the command line. Of course, there are benefits to command line interfaces. One is that by expressing your intent as code, you have great ability to automate by putting things into text files with variables as needed. You can collaborate by sharing code, even if it's just copy and pasting or looking at other people's examples. Hello, serverfault.com. And of course, you can corroborate that the change you're expressing in code is actually what you're wanting, expresses your intent by using version control systems so other people can review your code before it goes into production. So lab 2, let's install Cloud Foundry and actually use it to establish a session in your terminal with cloud.gov. The Cloud Foundry releases are available for download on GitHub. I'm going to move through these slides. The URLs are in your notes, either online or in the printed version. So go ahead and go there, get the installer appropriate for your systems, go through the installation steps. I haven't shown those steps because they're different for every platform. I think most of you have installed software in your systems before. If you're on a Mac, you can, with Homebrew installed, you can just do brew cask install Cloud Foundry -cli. And if you're using the remote workspaces, Cloud Foundry is already installed. After the installer has finished, if you run the command cf, you should see a list of command options. And that looks like this. CF, and you get back the version number, and you start getting a bunch of different options for different commands that you can run. And I'll wait here until folks, until most of you have Cloud Foundry running. Can you raise your hand here if you have if CF is working for you? All right. A few people still working on it, raise your hand. I'll pause just a little bit longer. Because if you already have it installed, I'm going to move on with the login, and then we'll take a somewhat longer break for the rest of you to catch up. I'm going to show a short video here because this is where I've seen some people get confused. The login from the command line is the command cf login --SSO, single sign-on, and then -A and the URL for API. You're only going to have to do this the first time you log in. It then remembers your API going forward. To confirm you've logged in, the cforgs command will list some of the organizations that you have access to. It might only be one, but that's okay.
Peter, one quick question.
Yeah.
When, people are saying they're still working on it right now online, so just...
Okay. The way I've structured this is that I get to a point where I say further exploration. So if things are working for you, you can continue poking around, and then we'll pause there and make sure that everyone else is caught up. After you type that command, you're going to get echoed back to you, get a one-time code at this particular URL. You visit that URL, finish the login process to cloud.gov, and you get a one-time password that you either type or copy back in. Let me just go ahead and play this. So here, I'm typing the login command. It says get a one-time code. I copy that URL, paste it in to the browser, and then I agree and continue, do the cloud.gov login, enter email address, password, and token. Then it displays a one-time password. I copy that from the browser and paste it into the terminal. If you're using the web browser to access the Amazon Workspace's remote station, copy and paste doesn't work, so you're going to have to type the authentication code in. If CFOrgs, if you're logged in, when you type CFOrgs, you should get the name of at least your sandbox account. And I'm going to pause here then on the further exploration page. Everything's working for you. Try some of these other things and poke around a bit at what Cloud Foundry can do. And let's take care of questions. Any questions here in the room?
I'm getting a firewall error. Can you see what that command is here? Is it on here somewhere?
And this is section lab 2.2, if you're looking for the header. Okay. Other questions?
You said it'll take a few minutes for the organizations.
So if you go to the dashboard and you see, oh, I don't have it in this slide deck. Let me just see what's happening for you. All right, so if people are getting credentials were rejected, try again. Go back to the web page that has your temporary authentication in it and refresh it, because you may have had it there for longer than a minute, in which case it's expired. So then you get a new code. You'll copy that and paste it. You won't see the passcode visible when you paste it in. And that's okay. All right, now we get to do something for real on cloud.gov. Starting with a simple example of, I want my agency's website to be accessible at a public URL so the American people can read it. Well, we're not gonna take over your agency's URL this morning, not quite yet. We'll get there. Give us a few months. But we'll get something displayed at yourname.app.cloud.gov. Now, to do this, we've been following along with some of these notes that are in GitHub. We're going to download that repository so you have the lab materials available on your laptop. So we'll get our lab materials, and then we'll use the command Cloud Foundry push, CF push, to send the files to cloud.gov, which will package the site and start to serve it. You don't need Git installed, because I know that was a hurdle for some of you. So here are the commands for either the Mac Linux shell or the Windows PowerShell. In both cases, I'm going to assume that you're going to install the workshop materials under your home directory. Pick another directory and adjust the commands as necessary. But cd to your home directory. For Mac Linux shell, you'll type this curl command to download and save the file cgw.zip. Then you can unzip it and change directory to that unzipped directory. On PowerShell, similar, but you use the IWR command to save the output file cgw.zip, get it from this bit.ly URL. If you're on the workspaces, you can use 7z extract to unpack the zip file. If you're not, you should be able to use the extractor that's bundled with your File Explorer to do that. To check your work, when you run the ls command in cgw workshop master, you should see something like this. Admin, images, the names of some of the lab directories. I'm going to keep moving through these slides, and then we'll wait for let people catch up on the see your work, on the further exploration site. When you've gotten that unpacked and moved into that directory, you will use the push command to say all the materials that are in lab 03 site, we're going to push that up to cloud.gov. So you use this command here, cf push -f, give the path to the deployment descriptor, as it's called, for this site, and then give it your name. Unless your name, my fname, lname, be, I don't know, Tim Harvey or Tim Hayes or whatnot. What happens when you're in CF push is several things. First, the Cloud Foundry command line will load the files that you have in that directory to cloud.gov based on what's in your deployment manifest. There's then a staging process where an artifact is created that's called a droplet. And then when that's executable, it is running, and a route is created to the app. So this steps here in a sequence diagram, just to get a little bit of the flavor of the Cloud Foundry internals that cloud.gov uses. So CF push, you run CF push. The command line says, okay, I'm going to tell the cloud controller to create an app. The cloud controller stores information about the app in the database. The command line uploads the app's files. The cloud controller stores those in a binary data store. And then the command line says, start the app to the cloud controller. The cloud controller first finds available VMs in what's called a staging cell. The staging cell will bundle the whole application. When it's done, then the cloud controller will say, start the app to one of the production virtual machines, which will get the app from the binary store, then start running it and report the status. That can take 10 to 40 seconds, depending on the complexity of your app. Actually, I should say it can take 10 seconds to 5 minutes, depending on how many build steps, if you're building something like Java within cloud.gov. You should see when you run the cf push command, your results look something like this. It says creating app, a bunch of output. At the very end, it says, here's the URL, and at the very end, the state of the application you just pushed. You can now try accessing your site at https fname lname.app.cloud.gov, and it should just say hello.cloud.gov. So when you can access your site, you can try the following steps. What happens when you use HTTP? How do you get info about your app? And so on. But we'll pause here at this slide while we get everyone through the steps of downloading the labs and getting their site actually running. Okay, we're back. Those of you who had remote Amazon workspaces provisioned, it seems that your agency spam filters may have either blocked the invite entirely or sent it to spam. Do look for something that has the word workspace in it from about 10:30 last night. If you didn't get that at the next catch-up break, drop a message into YouTube chat, and I will send you an invite to a non-government account. It's still valid. It just sends you an email so you can follow the link to finish the registration process. And then I tear down these workspaces at the end of the workshop. Now, Great, we've got a static site up. What we want is a dynamic web app so that users can actually interact with us. This time we'll use CF push again, but we'll change to a different lab directory to stage and run a dynamic web application. And you'll also see some of what's in the deployment descriptor file, the manifest.yaml, and the role that it plays. What it does, it provides application metadata to Cloud Foundry. And we use this to set non-default settings like maybe it doesn't need a full 512 megabytes of RAM or a full gigabyte of disk space allocated, because for a workshop, we don't need that much. So I've specified lower values for that. And then there are other things you can specify, such as particular routes or the relationship between workers and web apps. In this case, Sinatra is just a Ruby web framework. The deployment process is the same for any language that is supported by Cloud Foundry. But first, let's revisit what happens when you run a CF push. These are the same steps we had before, but I've updated it because now we're sending app files up for the app. In the staging process, we're creating an executable artifact and all of the build dependencies for your application that the runtime needs is bundled into the droplet. And this is a job of the build pack. And once it's running again, a route is created to the app, and the app starts on the application host. What Buildpacks do is they facilitate creating a runnable artifact called a droplet. And that's the combination of the application files that you send up, plus all the runtime dependencies that are needed to run, which then builds the app artifact. These can either be fetched from standard repositories, but if you want to bundle all of the dependencies ahead of time so that there's no dependency on external internet access, you can specify that your application does that by providing all of those dependencies at push time. The applications are started on specialized virtual machines called cells. Oh, sorry, someone had asked about Buildpacks earlier. Is that enough about Buildpacks for now, or did you? Yeah, so the Buildpacks, we have like 9 supported languages. If you wanted to run something that's not supported by one of the stock Buildpacks, I had someone ask about running a statistical application under R. There are lots of Buildpacks available that are open source. So you could go ahead and say, build this application to provide a statistical service on a web page that's backed by R, and you can provide that Buildpack. What we do with the Buildpacks is we make sure they're always updated to the latest release. So if you need to get the latest version of Ruby or Java, it's a very simple maintenance application step just to restage that application so it picks up the latest build dependencies without actually changing the code that's running. Anyhow, the apps start on cells. If it binds to a TCP port, then it'll receive web traffic. You don't have to have a web app. You can have just worker apps that are there listening for events, like watching a queue or getting files from S3 and doing video processing. And we'll explain how Federalist does that here at our next break. Just to give a simple diagram, you as a consumer hitting an application that's running on Cloud Foundry will hit the router. The router will determine which of multiple virtual machines to send the request where your instance is running. And so multiple applications are distributed as instances across multiple cells. So take a look at the manifest.yaml and determine how much memory and disk is this application using compared to the defaults of half a 512 megabytes of RAM or a 1024 megabyte disk quota. And if you take a look at that, you see that we specified deployment manifest that's quite a bit less than that. Now, when we launch this application, the name that you have running in your sandbox will still be cglab, but we can't have multiple versions of cglab running at one URL within cloud.gov. So the random route true will append a couple random words to the name of the application so that the routes don't conflict with each other. As before, to push this application, you run cf push -f, the path to the manifest, lab4 app manifest.yaml, the name of the application. And when that runs, you should see that it's downloading a Ruby build pack. And when it completes, when the push completes, you'll have a URL that has some random words that you can follow to see the new version, a new application you have running. If you interact with the web page, you can see you can enter in a name, and then you press submit, and it says hello to you. The other step that we'll do in this lab is to take a look at the status of the current application. The command for that is cf app, and the name of the application, cf app cglab in this case. Look for something like how much memory and disk it's using. And the output should resemble how many, like this, how many instances are running. And I didn't highlight at the bottom, but it shows how much memory and disk are in use. So a question that came up here from some folks who are ambitious and moving ahead is, would I be able to connect an application to an external database service since we don't yet support Mongo as a standard service? Absolutely. You would create what's called a user-provided service, and you tell the cloud.gov application that it should connect to these particular connection URLs. And then for demonstration testing purposes, that should work. If something like that's going to be a operational need for something wanting to host with cloud.gov, then talk to us and we can revive our experimental Mongo cluster and make it production ready. Oh, folks, it seems like people are moving fine with getting that application running. So that is fine for showing that you have a dynamic application that can take an input and do something with it. Does it store anything anywhere? No. And any useful service on the internet is going to have a data store. So let's provision a data store and use it in our application. First, and this is where we start connecting our apps to the services that are available within cloud.gov. We have a marketplace that you can browse, and things can be within there are either free or they're available with a paid account. You'll use the create service command to provision a service that's associated with your space that you're working in. And then you need to tell the application and the service to talk to each other with what's called a binding, and use it, and you'll use that command. And we'll see that the application gets information about what it's connecting to via environment variables that are set within the running application environment. So the steps in this lab is first to run the cf marketplace command to see what services we provide at this point in cloud.gov. You'll look for something that's called Redis 32, which is version 3.2 of the Redis data store, and you can get details about that particular service with the command cf marketplace -s and the name of the service. Something to ask yourself, what's the max memory available with the micro size plan, which is what we'll use today. And the output you'll get from this shows that there's a couple different Redis options, and you'll see with marketplace -s some of the details about the HA, the standard plan, and the micro plan. At that point, you can go ahead and create a service. The format of the create service command is create service, the name of the service, the plan, which is essentially the size. Is it micro, standard, mega size? and then give it a name. And that's a human readable name that helps you associate what the service is for. In this case, I'm calling it cglab-redis. Creating the service will take about 40 seconds. So after a minute, when you run the cf service cglab-redis, it'll show the status of that command. And you'll want to look for something that says that status create has succeeded. The next section of the lab, section 5.3, is to associate the service and the application with the bind service command. Your application needs to know that cglab-redis exists, so it can store data there. So you run cf bind service, the name of the application, the name of the service. If you're curious how the application cglab knows about the service, you can use the environment command to cf to view those environment variables. And if you check your work there, the bind service command should succeed. And when you look at the environment variables, you should see something called vcap services and an interest for Redis 3.2. There's a lot of steps in this lab, so keep moving forward. At this point, you can push the new application of your version, the new version of your application. It's the same as the other CF pushes we've done before, only you're pointing to a newer version of the application. Something to ask yourself after you do that, has the URL changed for this application or has it remained the same? At that point, you can visit the app at the URL that's echoed back at the random route and take a look at what it does. And here's the output you should expect from the push with the URL at the end and showing that it's running with a certain amount of memory and disk made available to it. And when you visit the web page and refresh it, you'll see something that looks like this, saying how many times you've responded to a particular request. And then if, as an optional exercise, you can go ahead and scale up the number of instances that are running this application. And then when you go to the web page, you'll see that you're bouncing between instance 0 and instance 1 of the application. And the data store is keeping track of which instance has had a certain number of visits. Just to review, as we said before, that's because the router is seeing what instances are associated with this running application and will route traffic appropriately between them. Okay, great. At this point, we have a web application in the cloud that has persistent storage and that has scaled across multiple instances. And we did this with some stops and starts just in the context of a morning. This is not a production-ready application. If you go to the /env path on the application, it spits out all of the environment variables that are available to the application, which is something you would never do in a production app because it includes the connection URLs. But it's in this app just so you can see what things are available there, passed in as an environment variable. We'll see other problems with it as we go on into looking at logs and debugging. I mean, you as a engineer, program manager, security person, need to know what your app is doing so you can debug it and monitor it. And in this lab, we'll take a look at the logs that come from the application, the events that Cloud Foundry has recorded about your application, and do some live debugging over SSH. We don't actually do the restage maintenance step in this lab, but as I mentioned before, when there's an update to the underlying build pack for Ruby, Java, Python, you give the restage command to tell Cloud Foundry, take that copy of the application that you already have in your binary store and rebuild it with the latest dependencies. This is the sort of thing that Equifax probably should have done I should probably not say that. This is the sort of thing that is an important part of maintenance to make sure that an entire framework upon which your application is built is regularly updated in case there are bugs and security vulnerabilities to be closed up. So you can view the current activity of your app with the logs command. You're probably getting used to this now. You type cf, some command name, and the name of your application. Same thing, cf log cglab. You start pressing refresh on your web page, and you'll see a bunch of logs streaming by. And they'll keep streaming until you press Control-C, because it doesn't know when you want it to stop. Run that and take a look at where the logs are coming from. Do they say the name of the cell, the router, whether they're coming from an app, or from some other component within Cloud Foundry? And you should get something that looks like that. You'll notice that when you refresh, you only get logs from the router, and that's because the application itself wasn't written to actually give any log information about how it's performing, which is poor design, but that's expected because it's something that I hacked together based on some public code for this workshop. As we mentioned earlier, though, in the overview, all of these logs that we're viewing now are automatically aggregated, written to a Elasticsearch cluster, and made visible in a log search service called Kibana, which has some of the features of Splunk, but without the price. So you can view the logs for your app, because we split them out by organizations in space, by going to logs.fr.cloud.gov. And the UI has a lot of features in it, but essentially if you just go to the search box, type ERR, and press search, then you can find any error messages that have been emitted by your application. At that point, you'll see that if there are some results, it just gives a one-line summary. There's a little triangle next to it. If you click that, it expands everything about that log message, and you can look at what the actual message is. And you can see then, if our app is giving an error, what is that error? And does it actually matter? And just a bit more of a view, error in the search box, search, and then down at the bottom, when you have a result underneath the histogram, it'll expand that, and you can see the information about the error. In addition to logs generated by your application in real time, Cloud Foundry keeps track of what has happened to your application with what are called events. What you don't want to see are crash events. That can be indicative of you allocating 16 megabytes and your application needs more than that, it runs out of memory, crashes. Cloud Foundry very kindly restarts it for you, but it's going to be a messy experience for your users, so you don't want that. And check your work, you can see information about how many instances are running and when things got started, and so on. By default, your spaces that we provision for you in Cloud.gov's Cloud Foundry have SSH, secure session, enabled to your application instances. If you run SSH and connect to your application, you'll be connected to a Linux container, and you can see how many processes are running. You can connect up a debugger. This is there not for production maintenance purposes, but for application debugging. Any changes you make will be wiped away as next time your app instance gets rotated, which probably happens at least once a week because we are continually doing maintenance on the underlying platform, so that the particular instance will go away, even though your application is still running. You can, to disconnect from your SSH session, you'll need the exit command. Otherwise, you'll be wondering why your commands aren't working, and that's because you're connected to a remote computer. not to the workstation you expect to be. So when you have logs, events, and SSH working, you can try looking at some of these other avenues for exploration. And then we'll move on to how to delete applications and services to tidy up after ourselves, and we'll hear from Will about the Federalist experience on cloud.gov. So someone asked, the Redis service that we instantiated, can other apps use that same Redis? And the answer is yes, if they're stood up within the same space. But every space is its own logical domain, so it wouldn't by default be able to talk to your production version. Okay, that was not as many steps as the prior labs. Everyone seems to be caught up. We will move on to managing unused resources so that you're cost-effective and secure. These resources are currently being used, and since they run in a sandbox, we will start rotating out sandbox services and applications after 30 days. But to be tidy up your workspace, if you want to go ahead and delete your applications and services now, we'll see how that's done. In fact, if you do it, then you can know how to start everything up again. It's just a matter of CF create service, CF push app, bind the service, push it again or restage it, and you're back running again. So you might just go ahead and delete all these things, stand them back up again just for your own satisfaction. So, but regardless, unused apps and resources cost something to run, and of course, anything that's not running does not present an attack surface. So we'll clean up today with the delete command, which takes care of an app, delete services to get rid of Redis. And then, as we mentioned earlier, the router keeps track of the URL that should be mapped to a particular application, and we need to delete those routes. Fortunately, there's the delete orphaned routes that takes care of them in bulk for us. Most of these delete commands will not do anything until you type Y or yes and press return. So if nothing's happening, it's probably expecting a response from you. So to know what you need to delete, first you need to list what's running. And you can list all of your running app, CF apps, and then go ahead and delete each one. In my case, that would be delete cglab and the Peter Burkholder app that I had done as the first demo. And you see there, you get the listing of the apps, and of course, really delete the app cglab, and yes, I mean that. Likewise, with services, you can list them with the CF services command, and then delete each one with the CF delete service command. And there should only be one service running, the Redis one. You can delete that. And roughly the same output. List the services, and then confirm the delete service. And lastly, you want to take a look at the routes that you have enabled with CF routes. The routes will all may have a application connected to them, or they may be orphaned if there's no longer an app connected to them. You can delete routes one by one with the delete routes command, but the syntax is a little clumsy, and generally it's faster in a sandbox or development environment just to delete all the orphaned routes with the CF delete orphaned routes command. And you can see here the output from the CF routes shows two routes for host Peter Burkholder app.cloud.gov cglab random word, but there's no app. Underneath the apps column, there's nothing there. So those are orphaned routes, and they will get deleted with the CF orphaned routes command. And at this point, these commands should show nothing running if you've done this correctly. CF apps, CF services, CF routes, and you have completed the workshop and tidied up after yourself. Give yourself a round of applause. Some resources here that you can use to learn more about cloud.gov. I would start with the docs page that our team maintains. Britta Gustafsson is an amazing documentation writer, and I often find that our explanations are better than what's available in the community documentation. The community documentation is more comprehensive because it covers in detail every command and option. But the starting place for working with cloud.gov is our own set of docs. There's a new book out from O'Reilly. I know nothing about the quality of it, but it's there, so it should be up to date. And Pivotal also publishes some ebooks that are available for free download about how to write applications for cloud.gov, what it means to be cloud native. There are some courses available. The one from edX is available free. The training materials from some of the Cloud Foundry summits are quite good. In fact, I borrowed from them very liberally in putting together this workshop. They are released under an Apache license, so I think that's okay. But it goes into a somewhat different direction with some of what it is they're trying to demonstrate. And if you have inquiries, email us. And I'm a fan of Twitter, so follow @18f at Twitter.